Okay, good evening everyone. So today we are going to discuss about network address translation, which is we call it as NAT. Okay, so why we need NAT? Okay, so which we call as why we need a network address translation? Just imagine you have one big LAN area. Okay. Say example, let me save this guy here. Let me open, let me take this. So we have a network here, right? So just imagine, just imagine this as a WAN router, okay? Just imagine this as a WAN router, okay? So this WAN router is connected to another WAN router, and the other end of the router is LAN network, okay? Okay? So just imagine this WAN router is connected to another WAN router, okay? Just imagine this is a router, okay? And this is connected to one LAN network, okay? Okay, this is connected to one LAN. Just imagine. And now imagine this WAN router is again connected to another LAN router, another WAN router. So we have three WAN routers here, right? So they are all connected to a headquarters. Let's call it as headquarters, okay? And we have 1, 2, and 3 regions, okay? Let's call it 3 different cities, okay? So these are all WAN routers. So each WAN will have assume like these have 500 users, right? Let's assume these have 500 users. These have 550 users, okay? Let us assume, and this guy, let us assume they have 700 users, okay? So how many LAN machines we have here? 500, 550, and 700. So that is a lot of IP address space, right? So for example, we have used some subnets here, okay? Let us assume we have used 10.23.45. So how many addresses we can get in the subnet? Only 254, right? We can only get 254 addresses out of it, right? Only last option. But we still have 700. So we need how many more? We need at least 2 more. We need at least 2 more addresses, right? We need at least 2 more addresses. So here itself you need 3 subnets, 3 networks. That is a waste of lot of public IP space, right? So and also it's very expensive to use public IP address like this. Give me one example of public address. For example, 2.34.5. So if you assume this is one public address, it's a lot of space and it's a lot of cost consuming. So to avoid that, we will use private addresses inside the LAN area. Okay? For example, this LAN will have its own private address, private subnet, private subnet, private subnet. Just imagine if these 3 WAN networks are autonomous. Though they are trying to route to one headquarters, those 3 WAN routers are organized by 3 different network groups. Just imagine if this network group is using same public address as this one of the hosts here and also one of the hosts here, right? You know what I'm saying? We are using private addresses for the LAN and we are using public address anyway on the WAN interface. Can you give me one public?
We are reusing the same instead of the private network, the network addresses. Public, so private networks, are we going to reuse the same public addresses in each private network?
Exactly. So, private addresses. So, what are the private addresses? We know, right? Private address range. We have 10 dot subnet, We also have private address in 170. We also have private address in 192 range, right? We have private address. So these three are autonomous. So they don't know which private address they are using in this LAN. They don't know which private address they are using in this LAN. They don't know which private address they are using in this LAN here. So these three LANs are using their own private addresses, but they both might conflict. So this might conflict and this might conflict. Because there are so many private addresses, there is a more chance that they all are using 192.168.2.1, okay? So there is a big chance that they are all using 192.168.2.1. There might be one more 192.168.2.1 here also. There might be one more 168.2.1 here also. So there is a big chance that these three local area networks from region 1, region 2, region 3 might use same private address. So when they go to the wall headquarters, what will happen? These three will conflict here, right? These three will conflict. For example, if the wall headquarters wants to send a packet to 192.168.2.1, and the three, and the three local area networks have same private address configured to one of their hosts. What will happen? The packet will loop here and it will drop eventually. Because all these routers will say, all these WAN routers will say, I have 192.168.2.1, right? Because all these WAN routers, routing table will have 192.168.2.1 in their routing table. This one will have, this one will have, this one will have. When it propagates to all headquarters, what will happen? It will create a mess. And the packet will be dropped here only. It will form a loop here. Inside the router itself, it will form a big loop. Because every router is, what is saying? It is acknowledging that I have this IP address in my routing table. So to avoid that, we will do mapping at the routing net. So we will translate the group of private address into set of one public address. Okay? Okay? So how we do that? So we will pick a pool of address, okay? How we will do that? We will pick a NAT pool. For example, here I picked one big pool, right? You see? 171.160.16.10 to 254. So I pick it from 250 addresses, right? And I am using this pool to convert all the network addresses. You see there is a LAN here, right? Let us call this as Tampa LAN, okay? Let us call this as Orlando LAN. Okay, let us call this as Orlando WAN public server. Okay? So there is a WAN public server here, okay? In this network. Okay? And this is a WAN network here. But we have one LAN here. Just assume. We don't want the 171.68.1.1 subnet or 1.2 or 1.3, whatever IP address in this LAN network, propagate to the outside WAN and towards public server. Why? Because there might be one more router connected here, right? As I shown here, there might be one more router connected here which might have the same IP address. What is that? 171. There might be 171.61.1.1 like this one here also. So that might conflict. So I'm getting a NAT pool and defining it on there, and defining it on the WAN router. So whenever I define this NAT pool, just in case if the NAT pool conflicts, if there is already existing WAN IP addresses on some other WAN router, this WAN router or this hub will give a direction that is already defined, that is a bad NAT table. You can test that. Connect to this router, another router, and define same NAT pool and see what will happen when you configure, and after configure try to IP routing. So the basic concept is you are picking some group of private addresses and then translating it into a public address. Or it can be any address, not necessarily public address. But just make sure in real world, any WAN interface that is connecting to outer WAN or ISP, they always configure public address. Because public address is what it understands. You cannot configure private address on the WAN interface to outside ISP or outside LPLS or outside channel. Yeah.
One question, Harsha. The public address, is there a possibility that even the public address is not on each other?
Public addresses, see, if you try to configure the same public address this here, connecting to WAN router, it will say bad subnet or bad IP, mask or bad IP address, something like that. Because it will be already constructing somewhere. And you will immediately see the routing loop form. The World Wide Web or ISP will make you, will send a, it will drop the packet. Immediately when you test its routing, you will immediately find it out. It is resolving. And also at the same time, pick any public address and do ls lookup on World Wide domain. It should resolve with respect to some. For example, yeah, go ahead.
How will you define which public address? Like, there will be a lot of the private addresses, right? Out of that group, which one to decide as a public address? Like, which IP address to give as a public address? How will you do that?
Okay, you have public address pool, right? Let me show you.
A group of private addresses, like suppose in this 10.1.1 to 10.1.2 somewhere we have the public addresses, right? Out of that private addresses, which one to assign it as a public address for that group? How will we know that? Which one to?
So, as a network engineer, you have to plan which public address you have to write. For example, I will show you an example. If you say that who is 19.23, it will say Ford Motor Company, right? So you cannot use this public address. You have to buy it. For example, this company here, they purchased the entire subnet of 19.19, right? So entire class A 19 is occupied by one enterprise. In the same way, if you want to assign some public address to your company, you should request your network engineer to show reserved public address for each enterprise. Yeah. So those public address you will already be purchasing from the public domain. Somebody might already reserve it, but there are lot of parties that sell you public address. Purchase public address. We'll see how many results will come. Public address network. Right. And so, right. So let's do it. Microsoft offered to buy Norton 66 for IP4 addresses for $7.5 million. You see, that's how they do business. Public address is a lot of business. They ran out of lot of public address. That's why we have IPv6 now. This is a big mess, right? IPv4, how many you can give?
Yes.
So this is what it is. So you can purchase. You go here. You can submit a prior address. Okay? And because they are telling you public address. So your company will have public address. So you will use them very wisely. You understand what I'm saying? Because you cannot just go and assign public address to wherever you want. For example, this is a WAN router. On the other end of the WAN router, I will use some private address. Okay? So that I can NAT the private address to a public pool here. And then NAT into it. You know what I'm saying? So, you no need to waste so many public addresses. And also, what I can do, you cannot do NAT. NAT will not help you that, but what it will help you is you can redistribute your private address into one public address here, or into this network. So NAT will help you in case of duplicate between three different LAN networks. So NAT is must if you are using private address inside LAN, and if you want to broadcast or exchange the routing tables from LAN network to LAN network, you cannot advertise LAN IP addresses to outside, right? You can only advertise public address. You understand what I'm saying? So you will be picking all the public addresses or private addresses, and you will putting in the WAN in some pool, and then each time you send one packet, it will tag to some IP address in the NAT pool, etc. No,
so the NAT pool is like listing all the private addresses.
See, NAT pool you can use public addresses. That doesn't necessarily mean every time. If there are 100 private addresses, it doesn't mean 100 public addresses you are NATing into the outside one. Whenever you are forwarding the traffic, it will wisely use one public address line. But in the end of the day, it will exchange the NAT pool public addresses into outside one. I will show you how it happens, how the NAT address works on a LAN router. You know what I'm saying? It will exchange this IP address into the public network. Okay? You won't find the network entire table here, but you will be able to route it. Because the network address transfer is happening at the router, not at the WAN network. You know what's the difference? You are able to understand, right?
Yes, I'm understanding, but the thing is, right, like for the router we'll have many other connected, right? So which will have private addresses.
Okay.
So
if you have so many other local area network routers connected, you cannot use same private address in another router. Why? Because anyway you will not be using, right? If the local area network is connected to one area WAN router, network engineer will be able to manage all the local area networks, right? So he will wisely use different private address within the one region. You know what I'm saying? So there are 30 other routers connected to this router. You cannot use same private address range to other routers. But if there is another router connected to here and has a lot of LAN network, you can use same private address as here because they are translating eventually when going to the outside router. They will not translate into the same private address, right? They will translate into public address. Understand? So they will redistribute the private address into one WAN IP network. So 1,000 private addresses will be redistributing into maybe one or two public WAN IP addresses. So because you will only have one or three serial LAN interfaces, but in the LAN side you will have 1,000 LAN interfaces. You understand the difference? The WAN network, okay. See, WAN network. See, imagine these both are WAN routers, okay? So WAN routers maximum you will have two serial links, okay? Tunnel 1 say, tunnel 2. Or maximum you will from this side will have 3-4 tunnels, okay? Or you can have T1 line, T2, or you can have OC3, OC8. What is the difference between T1, T2, OC3, OC8?
These are optical cables and those are...
Yeah. And they are higher than, this is 1.4 MB. I don't know. To verify what the speed of NB or NB. Which one? There is a lot of difference between NBPS and NBPS. Okay. So how many networks you have? 1, 2, 3, maximum 4. But if you go to the LAN, you will have this router will be connected to 2 or 3 downlinks, okay? To a layer 3 switch. This layer 3 switch will have so many stacks. In the chassis of layer 3, you have so many line modules. Each module will have so many hosts. Each will connect to hundreds of LAN end devices, right? And also there are so many VLAN, virtual LANs. Each VLAN might be in different networks. You see that? How many networks we have? These are all private networks. While going here, you have one big layer 3 network, which is also can be private or public. And while coming here, how many you have? Only 3 or 4 public addresses, public network. So what happened to all these private addresses? They are solved into one big table, okay? Private address table, okay? So we have one big private address table here. And this private address table is what happening, is regenerating into one public address table. So this public address table is where we only have public address. How many in here? Only 2 or 3 networks, right?
Yeah.
1, 2, 3 networks. But private address you have 1, 2. Actually they can have 4,950 something. You can configure this many VLANs. I don't remember the number, but it is in the thousands. Figures will be in like 4,000 something. See, this is how the regeneration of different networks work. On the WAN router, you always redistribute, I'm sorry. You redistribute all these networks into one public network or multiple public networks. So redistribution is the answer to your question. You understand?
Yeah.
So redistribution, so you will have redistribution between OSPF and redistribution between RIC and static. You remember, right? We used to call the redistribution copy commands on OSPF and EJALC, right?
Yeah.
Redistribute static, regenerate static. These some commands. I will show you.
Okay.
How we redistribute the static routes into OSPF. I will show you. Okay. Let's save this thing first. So this is a very good doubt, and everyone should get this doubt. Since there are not many in this class, this is a very good doubt for who are reviewing this video audio. This question is how the redistribution is work. So to answer that question, we have configured redistribution already. So running stuff. Okay. When did I use the redistribution command? This is the word. Yes. Okay. So this is one kind of redistribution. So what is default information ordinate? If you have any other static route or default route, this will redistribute into these 2 networks. Okay?
Okay. Okay.
For example, let me show in adress. Adress and OSPF we discussed really good. So we should be able to understand. So run here. We did redistribution on the ASP interface. I begin with the redistribute static command. So we have static route here, right? It is going to see here what we did redistribute static. So if there are any static routes like this, they will be redistributed into EIGRP table.
Okay.
So you understood, right?
Yeah.
How all the private address will redistribute into WAN address. They will use redistribute command. So you can also redistribute between. OSPF and EIGRP.
Yeah.
And eventually you can redistribute all protocols or routing protocols into BGP. Okay? This is not a routing protocol. BGP is an algorithm. It will use the routing table given by OSPF and EIGRP, whatever you configure. And it is a path vector, okay? It's a BGP will choose the best path by using the routing table of OSPF and EIGRP. So BGP is a very broader topic. It's out of the scope of this class, but BGP will use routing table given by, so for example, here, right, we configure serial link or OC between two WAN routers. On these two WAN routers, you use BGP to wisely choose which path because they will go to different areas. So it's very big network, okay? So many hops you will find. You will find at least 300 hops. So BGP will make sure they will use the best path. So it's a BGP the best path algorithm. We will discuss this time permit BGP and the end of the class. So you understood, right? How it is redistributing? So many private addresses are used to putting in few public addresses. Okay? So let us start the network address translation back again. Let us move back here. Remember, we have earlier discussed about static route, default router, next hop. So we have one router here. Okay? From here to here we can ping, right? For example, enable show IP interface brief. Okay? So what is the interface here? Fast Ethernet 00. This interface you can ping from this router, right? What is the fast Ethernet IP address? 192.168.1.1. You can ping from. We have routes from here to here, here to here. We can ping here. Okay? Ping it. When you ping it, you can absolutely ping it. You should be able to ping it. Just give it some time to confirm. Maybe I did not configure it properly. So why it's up? Maybe I removed the configuration, but now it should do. Let me see. Whenever you are troubleshooting, you are not able to ping. Ideally, you should ping. We will figure out what happens here. So this is again we are diverting our topic to troubleshooting. What I was trying to show you is like how we are able to ping it, but it's not pinging. So I'm troubleshooting it. Where is the 192.168.1.1? No. There is nothing in the routing table. That's why it's not pinging. So this is some falsely configured, right? So we will open one more example.
Your voice is breaking.
I'm not sure why I'm breaking. Maybe some kind of interface. I want to ping the outside interface. It's been a big deal. So you able to hear me, right?
Yeah.
192.168.1.1. I'm pinging from server, okay? I'm able to ping it. Let me do trace route. I cannot do trace route. Okay? Let me do trace route from this router. I'm going to this network. The router doesn't know what this network is, right? But it can route there. Why? Because we have configured routing. Now see, it went to 1.1 to 2.1 network, and from 2.1 network, it is able to reach this part. Okay? So let me open one more example. Okay. Yes, this is the guy that gave us something. Trace route, what IP address? You see? Let's see, let's go with both. Not showing. Why?
Yes, it's fine.
If the routers are initializing, so they're not able to ping. So this guy is able to ping, but why this guy is not able to ping? No. So this is not list, right? We have to statically mention this network we mentioned here. But this network we mentioned it here. So right?
It's not what is it?
Yeah, static out. So you write it down on the 2.1, okay? On PWC, write it out. This is the next part. So what is the next part route? In between we have two-10 network, right?
Yeah.
This is next time network.
1841.
Yeah. So what we are saying is just telling out to half of this network. This router will have 30 other networks, let's assume. But to reach this network, we physically know it should half over this network, right?
1841.
Now it's two things. It's two traces. So how did it went? It went from 210.2.1. And then next, where did it go? 192.168.2.2. Right? And where did it go next? To this now. This is what network? 192.168.2.2. Right? Sorry. 1.1. So one network, two network, three network. Is what faithful closely it passes from this to this to this. So this router knows what is the IP address. Okay? At the same time, this router here knows what is the network configured on this here. Okay? Trace route to this network here, okay? To 10.210.210.0. Trace route there. I'm able to, actually I should give IP address, not the network. Maybe it will not go. Why? Can you tell me why it will not go? Well, from right? Okay. So 210.2, it has to go to this network. So 210.1, it just has to ask this network. It new nodes to enter this network here. But 210.2 is configured on the other end of the network, so it has to pass to the 210.1. See, so the node pretty much knows where which network is available. But what if you configure this as private address and you have 1,000 more routers connected in that private address? When you do the trace route, you shouldn't know what address it is, but you should be able to reach there. You understand the concept here? Yes. And what I'm trying to say is, let's go back to our NAT. What I'm trying to say is, you have one LAN here, okay? Let us say you have one more LAN here. Okay? Let us say you have one more LAN here. Okay? Right? How many LANs here? So, you are routing all this network to this router here. Right? And from this router is going to LAN. Let us assume this WAN router here connected to one other LAN. Okay, let us assume it is connected to another router, okay? Right? Let us assume this has one some other LAN area. Okay, just taking this as some other LAN. And this one guy is one LAN, right? And this one big guy is another LAN. Okay. Let me fill the color. I don't know how to fill the color. Okay, let us go. Yeah, you see, this is one button. Okay, and now I'm going to fill another color here. Okay, this is yellow. Okay, so boy, let us go this is yellow. Now there might be one region where they both are same color. Let us take red. See, blue and yellow are two different networks, right? Let us assume blue and yellow are two different networks. Okay? Are you with me, Kavya?
Yes, sir.
Blue and yellow are two different networks, but there is sync region. What is the sync region? The region with common IP address. So, by mistakenly, though these are two different LAN networks connected to two different LAN routers, okay?
But they have the same IP address.
Yeah, this is one LAN. This is one LAN. Let me create a bigger neat picture. Okay. So let me draw one LAN here. Okay. We have one LAN here, right? So this LAN has private address. This big LAN has private address. So these both are conflicting with some private address. So what you have to do here on this end, you have to do network address translation. Same applies to this router also. It has to do network address translation of all the routers that's coming from this end, right? You agree with me? So how we do network address translation here? Before we do network address translation, I will try to ping this LAN address from here. Okay? From this router, I am trying to ping this router, this address, this network, right? This router has a network on this end. So I am trying to ping 1.1.168.1.1. Let me see if I am able to ping it. I am able to ping it, right?
Yes.
Let me trace route it.
One, yeah, it showed the path.
Going the path, right? Okay. Now, let me ping from here. Ping 172 dot, 2 dot, 18 dot. Let me trace route. I'm able to trace route, right? we are able to trace out, we are able to ping, where the IP address belongs to where this. But go here.
But we
So
doing the other one, right? Are you doing from the LAN? We are
I'm
doing
pinging from the LAN. Yeah, I'm pinging from the LAN.
We didn't get this a third router, right? We have 3 routers.
No need. I've configured this LAN on the router itself.
Oh.
What to do? Yeah. That's a good question. So I configured this network on here itself. See here, you see 171.68.101 network in this routing table.
No.
But how we are able to reach there?
We configured it on the router itself. That may be the public address of that.
So what we are doing is, you see here 172 dot 16.88 117.16.88 117.16.180. This is directly connected here, right? This one. 117.16.88 is disconnected here. Apart from that, it doesn't have information of 171.68.192.202. Right?
It doesn't have
information of this. Right, but how is it able to reach it? This is how real world works. Understood, right? I mean, not about NAT, I'm not talking about NAT. If you go to public router, you will not find the local private addresses. What happened to all of them? They are all redistributed into 172.16.191, right? So route again. So I see wrong. The redistributed with network, this guy here.
Okay.
So this network, this one, they're all redistributed. This guy, which is an outside router, doesn't know how to reach this LAN. I mean, it knows how to reach it, but it has nothing of that information in its table. All this table is distributed into which table? This guy, this network address. I mean, in this example, we redistributed into one public address. But usually, routing protocols like OSPF, JRC, they have redistributed into this guy. Now, let's come here. If I do show IP route on this local WAN router or regional WAN router, will I find the routing table for entire network or not?
You should find it.
You will find it because it should know how to reach them. You will have routing table for all the local LAN. This LAN you have, this network you have. So hopefully if you configure this local area also, you will have entire thing on it. But when it is marketing or distributing these networks outside, it is distributing them all into one this network. All the table, it is redistributing into one table. All the network tables that are in here, sorry, not all of them, whatever is connected to 192, right? 170.158.190.0, right? That one, and whatever network, this network. It is redistributing into 116.190, not 250. Okay, let me show. What is the network say? 171.68.101. Let us copy this thing here.
That's what
it will be
the main public address is now 172.16.191.252, right?
Okay, see. Yeah.
So should we specify that also in the table?
Sure. See. So in the table, what is the public address here?
The last one.
This one.
The last
public
one.
address. Public address. Right? What is this guy here? 16.88.0. This is via this guy. So this is what? This is a WAN address, okay? Okay, we are removing WAN and public address. So 120.16.00, what is this address?
16.0.
This is NAT address. You know what I'm saying? This is NAT. We will talk about this. Okay? And 192.0 watching address is LAN. Right? Forget about NAT for now. This is LAN, right? So this is LAN. 192.168, this is LAN.
Okay, that's LAN. Okay, got it.
192.168.16.0. What is this again?
We don't have 16.0.
Yeah. What is this again?
Just a routing, but I don't see that address.
This guy, I believe, 168.0 is somewhere.
Is the down one? Because here this is 171.68.1, right?
Right.
We don't.
See, 170.16.0.0 is not NAT. Okay, this guy is NAT. Okay, 170.16.0 NAT means summary for LAN address. You see here, this is one network, this is one network, right?
Yes,
if you both combine, what is the route summary? 170.16.0. Understand?
Okay.
So this is NAT address, okay? 168.92 that is LAN address. This is how we are breaking the routing tables. 178.68.1.0 is what? It is also LAN, right? What is 171.68.0.0? It is summary address for
the middle route.
Yes. Right? So let me start with NAT and put it in between, okay? This is NAT.
I'm trying to understand that 170.
Yeah, you understand now. You will understand now. See, forget about, okay, which one you are not understanding? Which one you are not understanding? Tell me.
That's 16.0.
No, which one? This one?
Yeah, that's 16. Yeah.
This one? 117.68.16.0, this one?
Yeah.
This one is NAT address. This one, do not think about it. I will explain you about it.
Okay. I won't.
Just look at the LAN address here. So this guy, this entire network here, we are summarizing into this guy, right?
Yeah.
Sorry. This is one LAN network. Okay?
Into 68.0.
Yeah, this is one LAN network. Yeah. We are summarizing into this guy. So these two LAN networks, we are summarizing into this one, right?
Yeah.
This is one LAN network. This is one LAN network. And of course, this is also one LAN network. We are summarizing into this one. You understood? Right?
Fine, sir.
Hi, Kishore. So, and see Kavya here, this in the WAN side on, okay? At the same time, the other address is learned from this router, it is summarizing into
16.170.16.0.0.
right?
Yeah.
So all addresses it's learned from this side of the port is summarizing into this address. And also all LAN addresses it's learned from this side of the port is summarized into this address. So you can do summary, you can do math. This subnet and this subnet, the common part is 171.16. That's right?
Yes. So we're doing .0.
Yeah.
And the other one is 172.16.0.
Right. So what we are doing now is we have this address, right? Summarized address or whatever address. We are translating into this pool. 170.16.02, 170.68.16.254. So we took one network. I will show you. From 10.254. We picked some pool. You know what I'm saying? So what we are doing here is, we have 254 LAN addresses, okay, or 240 LAN addresses. So we are translating them into
one public.
Some 240 NAT pool, right? So how we are translating, we gave the command here. I already configured this, okay? So we call the NAT pool name as NET 171 because of subnet name. We can give any name. And I choose the pool, this pool. So 171 dot
So out of those 254, we can pick any pool then.
we won't choose. The router will choose. This is dynamically assigned. What is DHCP? Dynamic Host Configuration Protocol. We studied DHCP, right? You remember, Kavya? You forgot.
I think that was the class.
Okay, that's fine. So I will show you. Okay. So see, Kavya, here. This is DHCP server we configure. I'm going to add a PC machine here. For example, laptop. Okay. And I'm going to connect it. Say, which cable? I connected it. What cable this is? Type blue, not crossover. Okay. So I go here, Kavya, and I'm selecting DHCP. Which IP address it will get? Can you guess? I will tell you. I'm going to DHCP server. Let's see what is the DHCP pool here. Okay. DHCP pool is from 10.1.1.10 to 246 users. Okay. Same like what we configured on the NAT pool. First 10 address you will always leave empty. Why? I will tell you why. So what is the IP address which will get, Kavya, from 10.1.1 subnet only, right?
Yes.
See, it's got 10.1.1.16.
So after 10.1.1.10 to up till
exactly. From 10.16.10 to 254. Why we are not using first 10 static addresses in the pool? Because we want to assign them as static. Every subnet you do network engineering, you will leave first 10 to static. In the future, you might require static addresses, right? Like configuring gateway, configuring serial interface. You will not use DHCP addresses, right? You use statically hand-picked addresses. You know what I'm saying? Hand-picked static addresses. You should give some room in the entire subnet, like 10 IP addresses, 20 static addresses. For example, if this region has 35 servers that require static address, how you will define the subnet? You will start from 45, right? Because first 30 you have these servers, and apart from 35, you need 10 more static address for WAN interface and routing interface. You understood what I'm saying?
Yeah, one question. There, right, it started from 10.1.1.10, right? So should we leave 10 more, and shouldn't it start from...
it depends on the requirement. So, okay. Yeah, you are still breaking actually. It depends on the requirement.
Okay.
Right. So if you are 30 static, okay.
Start from 20, right?
Yeah, by default, you will leave 10 static addresses. You can also configure them as DHCP, but I'm saying good design if you want to design it better way. I always start with 10. If there are 30 static servers, I will say, okay, 10 plus 30, 40. That's all. So, where are we? NAT. So, you understand how we configured the NAT pool command here? Let's go back. IP NAT pool, how we gave range here.
So,
right? I'm sorry, what is your question?
No, we left the first 10 here also then.
Yeah, exactly. So from 10 dot to 254, it will pick any address dynamically. There is static NAT also. We will discuss later. This is what? This is dynamic NAT. Okay? This is what kind of NAT? It's a dynamic NAT. You understood, right? The NAT is? This is dynamic NAT. Because you are dynamically picking the network address translated from this pool. So, any address that is coming from 171.68.1.0, okay? 171.68.1.0/24, okay? So, example, the packet is coming from host 170.68.1.5. How it will be translated? It will pick any address from this one. So it will be translated to 171.68.16. Some address. 48. Something. So this router has no routing table of let's do so IP route. Okay. This router has no information of 171.68.16.10. For example, ping 171.68.16.10. It doesn't know where it is because it's not in routing table. And it also doesn't have routing information of this address. But when you are NATing, see, you are NATing entire 178.16.0. See here, Kavya and Kishore. You have the subnet translated into network address translated into which subnet? 16.0/24 though you have some static addresses. So you translated all this network into this network. Right, Kavya?
So this is
how will it?
0.0.
Sorry?
It should be 170.60.0.0, right?
No, 16.0 because what is our NAT pool?
Oh, okay. Okay, got it.
So, 178.68.1.0, this network, forget about the host here, okay? Okay? So, this network we are converting into this pool. And how will this network know that this network is on this router? It doesn't know. It will propagate all these packets to this interface. You look at here, what is the network address on this interface? 192.168.253. Right? Right? What is the network address on this interface? Not 254, right? Right? So this interface is 254. That means so right? So the IP address of this interface is 254. The IP address of this interface is 254. Now we are routing entire 16.0 subnet, right? This entire pool. So we are routing this entire 16.0 now to which pool? Statically route to which address? Which interface? 172.16.191.254. Understood, Kavya? So, we are putting the pool of address from here, and once they come to this router, on this router we have configured static routes. And here also we configure routing to this network and this network. This network you don't need to configure routing, right, because it's directly connected. So this route network is configured on this one, statically or RIP or OSPF, EIGRP. And this network will eventually share with this one if you configure OSP page RP as same as this one. So once the network table, routing table comes in here, we are translating all this address into this network address translator address. And this pool, we are translating into this IP address, to this network address. So eventually what will happen, this router will never know this network and this network, but it is still able to ping those IPs. Why? Because this router is taking the job to translate all this private address. This network is taking the job to translate all this private address into a public IP and then share the routing. I will do show IP route here and you will see all the routing, right? You will see all the routes, which I explained here line by line. Right, Kavya? You understood, right, the routing table here, but we translated this and we gave the interface via this guy. So this router will know if I have to reach 16.0, I have to go via this port. Now what is outside and what is inside? Now you can also give NAT pool here and translate all the IP addresses from this pool to here and give static route to this IP address. And eventually this routing table will, what will happen? See. So IP route here on this router. You have address of 68.1.0 and also you have address of 68.190.0. Right? Can I ping 172.16.191.254? I should be able to ping. Right. How? So IP route. The network not in table. Right? Why? Because we are network address translator. Sorry?
The 264 we have configured already in that place.
Yeah, but I'm saying how I'm trying to show you that this network table is not in here. It is translated here. You will never know what is outside here. And same way you never know outside what is inside here. Why? Because I will show you. What is the interface here? SI 0 by 0. You configure it as IP NAT inside. So there is a lot of network address translation happening at this, and also a lot of network address translation happening at this. So when you configure IP NAT inside here and you configure IP NAT outside, here you can give them dynamic or static or any pool. You can also give pool on inside also. When you give the pool on inside, what will happen? So whatever addresses coming from outside will be given a specific IP address from the pool and it will be advertised as or forwarded as some NAT address, not as a direct public address. You understand? Kishore and Kavya. So you can also give pool here. But for now, just to understand the topic, I am configure pool on the outside port, outside NAT. That is the whole concept. And the rest of the two command lines here, this one and this one, are routes for this network, this network, right? One from the 16.88.0 is route for this network. So on this router, we configured routes for this network, and 16.88.0 is a NAT address, right? Sorry, 16.88.0 is, I'm sorry. Yeah, 16.88.0 is just,
that is the LAN that we connected.
Oh, this guy, right?
No,
this we configured.
The last one.
Right, and I'll see, maybe I configured the start loop as address. So I think the same thing. 120.16.88.0. Where we configure this? Where we configure it, Kavya?
We have configured it in this 191.254.
This guy? Yeah, 16.88 is this network. 68.16.0 is NAT address.
No, actually we wrote
168.1.0 is this address. There is no confusion, right?
No, but we wrote one place that 16.88 through this 172.
See, 172.16.88.0 is this network.
Yeah.
See, how will this router will go in? We did not configure OSPF on OSPF here. So every route we know we have to statically assign it. So for all the three networks, this one, 1 and 2, we configured here, and third one is NAT inside this. These two networks we did not configure static routes because they are directly connected. No need to put the routes of this in the route. So this is how we are network address translating this LAN into and directly connected into some other connection. What is the advantage of this is whenever you are advertising it into a WAN or redistributing it to a WAN address, it will go from these two. Understood, right? So that you can configure as many as private address in a different WAN also. When you are going out, your network address translating it into some public address. Understood, right? Any questions? So we'll just go through the slides, okay? So just as it says, why we need NAT? Because we have shortage of IP4 addresses. So we cannot use public address wherever we want. Are you able to hear me? And you cannot allocate IPv4. See, allocation of last IPv4 address is forecasted for the year 2005. Now we are in 2015, 10 years. See, whoever engineered the IPv4 address space that will come first till the end of the world, it has gone. IPv4 address, though we have so many addresses, we ran out of public address space by 2005. So if you want to need a public address space for your company, you should purchase it from third party. So all the IPv4 are no more for sale. So you have to pay the price demanded by the owner of that IPv4 public address. Address classes were replaced by usage of CIDR. Of course, we are using subnetting, right? We are breaking small networks so that we can avoid wastage of networks, right? For example, if we need 30 hosts, we will use subnet mask /27 or /28, right? We will not waste by using /24 and assign to these two addresses. So there is one more workaround for this problem. The workaround is network address translation. So we can pick pool of 250 addresses and we can use them to point-to-point translate to one pool, or else we can statically give one public NAT address and translate all the pool of IPv4 addresses into private addresses into one public NAT address. We can do that. So Kavya, you have asked me that question, how we redistribute all the private addresses into fewer public addresses, right?
Mm-hmm.
That you can use static NAT addresses. Okay? This we already discussed, how we are translating the private address into public space, and also inside NAT you can also public addresses you can transfer them to NAT pool in inside, but you cannot redistribute all the public addresses into one public address. There will be exchange between the WAN using BGP at a ISP level. That is outside the scope of this talk, but I'll just explain it. So public addresses, you cannot redistribute them, or you cannot reuse them. But private addresses, you can use them, reuse them. You cannot use the private address as the WAN interface, but you can use one public address as the WAN interface and redistribute all the private address into one big public address. This is a big picture here, right? How you are mapping the NAT table with private addresses, and you are translating in the NAT table, and you are mapping them to one public address. And also you can pick a pool of NAT address. And also you can exclude certain private addresses to be NAT address, and you can directly redistribute. But at the end of the day, they will also be redistributed using a public WAN IP, not as a private WAN IP. So NAT pool, you pick whatever you pool, and the timeout value of 15 minutes, how long you can keep an association. So once you, for example, on the notepad, we assume that it will pick 16.47, right? This is a LAN IP address and it's went into a NAT pool. So this NAT pool, we assign .47 to .5. How long it can hold after it expires? So you are no longer using .5 for communication. How long it will expire? It will expire 15 minutes. Default. You can also change the time. So it will expire. So what will happen? It will be again available. So in the future, .7 came. It will associate with .47 again. Whereas in the real world, the DHCP, once the IP address is assigned to a computer, it is assigned as long as computer is online. If computer goes off the network, that DHCP address will be assigned to a new IP, newer computer. For example, your mobile phone, if your phone you are not using for more than 6 months and you deactivate your phone number, call after 1 year. It will be used by somebody else, right? For example, the mobile phone number I used for 10 years, I have deactivated it. I am actually not using it for 3 years. I didn't make a single call from that because I came to USA. And my mobile number in India, I did not use for 3 years. But before, when I was in India, I used it for 10 years. After 3 years, I went in India and activated my SIM card and tried to call. It was not working because someone else, the Airtel, it deactivated my phone number because I was not using it for 3 years and it gave to someone else. My number, which I was using for 10 years, is being used by some other guy. So all my friends who were in my friend list for 10 years, they were calling him. And everyone was calling him and asking for me. Just like, you remember, right? There's a movie, Shiva. So it will expire after it is no longer in use. If it is no longer in use, it will disassociate. So inside local, inside global. So this is very important term. So NAT is an inside global address to represent the inside host as a packet. It's sent through the outside network, typical internet. Right? We just shown it. So we are using inside global address, right? So that set of private addresses are sent to the outside WAN internet address. And the NAT router changes the source IP address of the packet. That is what is happening. 1.7 is the source address. The NAT address is 16.47 in our lab. That is what I am saying here. NAT router sends the source IP address of packet sent by inside host from inside local address to an inside global address as the packet goes from the inside to the outside network. If, in the case, if I assign the NAT pool here on the inside network, it will pick some IP address from the inside and it will assign it to the source address and it will redistribute into the WAN network. But in our case, we distribute on the outside network. So what is the difference between those two pools? Is there any significance? Let's see. NAT router changes a packet destination IP address sent from the outside global address to an inside host and the packet goes from the outside to the inside network. That is the difference. So, in this case, we will know what is the destination IP address that is coming from the outside. You know what I'm saying? Let me do trace route from here. Trace route 172.16.191.64. I am able to trace route to a public WAN address. Right, Savi and Kishore? Let me trace route here to a local area network. Trace route. What is the 178.168.1.1? I should be able to trace it, but it's for IP route. I will it is saying directly connected, but it is not, right? It is not directly connected. It is connected to some other router somewhere else. Let us do show IP route here. Oh. You see? We are an inside router. I am trying to trace the public address. I am able to, but I am able to ping it. It doesn't know where it's connected. Why? Because that is what is happening here. If you read 3-4 times, you will understand. You understood the license, right? They will able to pass the IP packet, they ping each other, but they never know where they are in the network. So I configured the outside global here, and the inside routers, they are not able to know where the outside is connected, because my routing is finally outside. So configure inside global, and configure the route.
One is the question. Can we go to the example one?
Yeah.
Here, right, for the router we configured on the near 191.263, right?
You can call, we call outside router, this is called inside router, this is router 1. So which router?
The outside router.
Outside router, okay. I configure a network on it. Yes.
So when we put in the table, right, so it said it passed on the other side, right, the 202, right, instead of the 253 for the other router.
I am unable to understand. Can you repeat again?
So how the configuration ones on the...
Okay, outside router I just configured static routes there. Okay, enable, show, run. You see, I just configured the default route.
Okay.
And this network and this network are directly connected. But for this router, I configured a static route. Default route. So whatever packets that come from this server to this router, they will go to this interface only. So I didn't configure anything else. No NAT on this router. You were asking whether I configured any NAT related commands on outside router, right? Nothing.
Yeah.
I did not even configure any NAT related commands on this router also. I configured NAT related command on FH 0/0, calling it as NAT inside. I called it as NAT outside. Otherwise, this router doesn't know which one is out, which one is inside. Because when you give IP NAT outside source list from the pool, it should know which port is outside, which port is inside, right?
Okay.
So basically, we are not propagating this table to inside local area network. And also outside area doesn't know where these are connected to. This way we also get security. We will never know how to reach the local IP address. We can able to ping them. We can able to ping public servers. You can try to ping public servers here, okay? You are able to ping the public server here. But when I say but, what I mean, you never know in which network table they are, how to reach them. So our public servers are also safe, right? You cannot hack them because you don't know routing table. All you can do is ping. You can do DDoS attack, but you cannot do anything. You cannot do anything. You can do spoofing like that also.
Somehow my mic is not working. Okay.
I'm sorry?
I will try to explain what you have said.
Okay, so going back, so any questions so far, Kavya? It might be confusing inside, outside, outside, inside. So there are three things you always must remember. You should specify which interface is outside and which interface is inside.
Yeah, initially I was good. After seeing inside and outside, I'm getting a bit confused.
Yeah, I will share my that lab with you. You go into the router 1.
Okay.
And see how I configured it.
Yeah.
So I specified one interface as inside and one interface as outside.
Yeah, once I see the exampling properly,
Right. So this is a bigger picture here. So where we are doing, so we are getting a source address destination address as 193 and this. But once we did NAT here, what's happening to the source address? It is becoming like a public address, it's becoming like private address. The packet that came into the router, once it was leaving to an outside interface, it became 10.47.10.10. So this gave, the outside pool gave, the pool configured on the outside gave the summary and it gave it out. The same here. Now, can you explain me what is the example here? We did NAT pull on.
On the router, right?
Yeah. See, our example, I did NAT pull on outside interface. IP outlet source list. So only IP public addresses that are coming from outside will take a different address. Very good example is this. The public address is once goes inside the router, it will pick some IP address from the NAT pool and it will go inside. So that is this example. In this example, we define NAT pool on outside interface and inside interface. So both IP addresses are coming from both ends. They will be translated into some other address. So there is no way if you put a sniffer here, there is no way you will know the actual IP address of this private computer. If you put a sniffer here, there is no way you know the actual, for example, if it is a public server here, if you put a sniffer here, there is no way you will know the actual public address of the, or else if you do define NAT here, there is no way you know actual public address of this server or PC here. So the NAT also gives you extra protection of safety, right? Because it's translated into some other address, right? The source address is showing here, it is translated into a public address here. Source address 10.0.010, which is private address. So once it goes to the outside LAN interface, it translates into a public address, right? And then from there it went to it. So next time this server will reply as a public address, 29.7. It will say, okay, I am 29.7, I am trying to reply to 28.5. So it will provide its life, this server will assume this 10.0010 public address as 138.76.28.4. Understood, Kavya? But on the network interface, on the port here on this LAN router, it will be get translated to 10.0.0.10 and gets into this system. This is the difference, Kavya.
Yeah. Since we did an outside and inside, so the response that we are getting, the 138.26.7 was converted into 10.10.
Right. So whatever the port you configure, it will be converted on that interface. In our example, we converting it on which interface? outside pool. So whatever IP address that is going outside will get a public address. But whatever address that is coming inside, not this page, I guess this will be a good example. So whatever address is coming inside, they will come as it is.
Okay.
But only the local address will be translated. This is a good example only. Here we are going outside NAT pool. So whatever addresses are going outside, they are going converted with a public address. But whatever addresses that are coming inside, they are coming as it is. They are not network address translated. So you found the difference?
I'm just
I
worried
think
about
not.
the 10.10.10.
I will explain. Yeah, I will explain. So
How did we get that address?
Okay. Now we did NAT. We configured NAT on. Okay. Let me see. We configured NAT on this interface. So whatever IP addresses that are coming inside.
Okay.
So whatever IP address. This is outside interface, right? This is inside interface. Now we configured NAT outside. Okay. So we configure NAT outside. So whatever IP addresses that are exiting this interface, so this is NAT outside, okay? Whatever is going outside, what will happen to it? It will be translated into a public address. So a private address has been translated into public address. Why? This is NAT outside. So we are getting the return address reply from private address 29.7. Okay, we are getting a reply back. So once it's the router, will it not translated? No, it will not translate. It is coming down as the same public address that entered it as it is. Why? We did not do NAT inside, NAT pool inside. If you do NAT pool inside, this will also assign some address that we assigned in the pool.
So
that is a different thing. Yeah, there is a confusion. Yeah.
No, my question is about the IP address. So the IP address of the LAN system is 10.10.00.10, right? Yes.
See, I will show you. I will explain. So this is private address, okay? Let us go back to our address. Assume this is Tampa LAN. Assume this is Tampa LAN. Assume this guy as, this network as, this WAN, Orlando WAN public server. Okay? Let us assume this is WAN public server. Okay? So I send a ping to public server. Public server, we always respond with public address, right? You will not go to private address. So it is going outside. But once it left my router, instead of promoting it as a private address, it became public address because I did NAT pool outside.
So that is the IP address of that router. Okay.
No, this is the IP address we given from the NAT pool.
Okay.
So you are asking me whether it is regenerating into public address of the router. You do not discuss about that. Just assume how the router will see if at all it is missing.
Okay.
It might eventually redistribute into some public address. It might.
Okay.
But
I was worried about that IP address.
Yeah, no, don't worry. It might redistribute into public address. But if you sneak on this interface, you will see this packet. This might be redistributing, but eventually the destination server will have this address that is network address translated.
Okay.
You can see, going back here, what I did here, I routed the entire NAT into public address. Let us assume this NAT pool as a public pool. I translated all this into this network, right? I did it. I will show you. Show IP route. (178.68.16.0), right? What is the NAT address? 178.68.16.0, right? You see here 172.16.191.252. Right. Actually, what I'm trying to say is, we will not see it as a routing table, but we redistributed this network into this network, right? So 171 dot so we just did swipe it out a while ago. I'm trying to get that. Actually, I myself lost. So what we are trying to explain here is, so this network table will not be here, obviously. So, but what I did is, I distributed entire. Okay. So I know what is the NAT pool 171 dot 68 dot 16 dot 10. Just so we distributed into this table, to this interface. So we directly distributed this IP address into the WAN network, not this interface. So we distributed into this entire network. So to avoid your confusion, going back, this entire 138.76.29.7 is redistributed as it is to go to this router. So on the public, if you click on here, you will see this IP address only. For example, in our lab, you will see this address. Just pick this address, 66.47. So if you finish here, you will find 172.68.16.47. Right? Did you understand, Javier? I clarified your doubt also. Hello?
Yes, I am here, sir.
You understood, right? It's very pretty clear. There is no confusion here. So this IP address, when it's going to the WAN interface, it will be directly distributed into the WAN network. It can also redistribute into different WAN IP address, but you can also directly distribute that WAN IP address, that is output of NAT pool, directly into the WAN network. You can redistribute that. Any question? So that going from there, we have different types of NAT. Static NAT, dynamic NAT, and also we have PAT. PAT stands for port address transfer. So when I say static NAT, before explaining static NAT, we did dynamic NAT pool, right? In our lab, we defined a pool of IP addresses. And from that pool, we are randomly picking a dynamic address. But in a static NAT, what you can do is, you can just tell that every address that comes from this network to give with one static address. The disadvantage of that is, if you have 35 addresses, you cannot wait for the first address to complete the transaction and then disassociate and then come back, and then other one which is in the buffer will come and translate point to point, right? That cannot happen. So what you have to do is statically assign 50 static IP address to each NAT. So if you have 10.110 to 10.50, right? So each private will be, you have to statically mention .7. And dot 11 if you want to translate, dot 8. Dot 13 you have to write config line, each configuration line for each address. So if you have 50 addresses, your configuration will look how big? It will be 50 lines. So that is statically assigning that. That is the reason if I give you example ahead with showing a dynamic NAT, it will be very clear how the static NAT works. Right? That's the reason I just begin with dynamic NAT example. So dynamic NAT, and then we move to static NAT. And the first is port address translation. I have to show with an example. What is the port number for DHCP? 53. What is the port number for HTTPS? 443. So, if you want to convert the traffic that is coming from a different port to NAT to port, you can translate port traffic also and make it look like it is coming from a different port. So that is port address translation. I explained this thing, right? You can read it out. So you have to do one-to-one mapping. I just told you, I have tried so many static commands. How to give that static command? See, one-to-one, one private address, you are matching it to one public. If it is 10.1.10, you will 200 or 1.1.10. If there are if there are 50 addresses to be translated, you will have one big pool. So you are giving a security inside, right? But that is a cumbersome process. So the dynamic NAT is still the same, but we are giving a pool and let the router decide how you will statically assign it. And also it will dynamically remove the IP address if it is not anymore working or anymore, making any transaction or anymore forwarding packet. So after 15 minutes, if it is idle for 15 minutes, it will give to the different address. In the meanwhile, it can pick from the other IP address in the pool also. So it's no big deal, okay? So, but however, mapping of interlocal to global address happens dynamically. This is all we discussed this, okay? The port address is very important. See, while going out it is port 23, but what is the actual source port? Sorry, while going out it is 1024, but the actual port address is 3014, not address, port number. Understood? Instead of IP address, we are not only transmitting the IP address, we are also transmitting the port address also. Much more privacy, right? You see? Private address. You see this picture, Kavya? I drew a similar picture long ago. So many private addresses you can translate into single public address. So you can give one network address. So all the IP that goes out will go to the public IP. Correct. So when the WAN traffic returns to the public IP, again this router will defragment and it break down the NAT table and it will send to all the stack. This way they all have reserved. This way you can figure IP. You don't need to do a big pool. You can just give one or two public address and have them mapped to the single public address. But if all of them are working at the same time, then there will be a lot of delay here, right? It will send all the packets to the same address. You see here, we are using multiple port numbers, but single IP address. So if you have like 10 different IP addresses, you want it to become a public address, but same public address, but different port number. For example, I will show you. We have, for example, we have 10.10.10.1, 10.10.10.2, so on 10.10.10.25. Okay, they will all translate it to one public address, say 23.24.5.1. But if it is 10.1.1, 10.1, it will be transmitted as 23.24.5.1, but port number, say 450. And if the next packet comes in 10.10.10.2, it will translate it to same public address, okay? It will translate same public address, but port number will be 556. You see the difference? They are all pointing to same IP address. They will go out at same IP address, but port number will be different. So when they return back, the NAT pool can break up evenly, right? It can reverse break up and it can send the packet back to the right source where it came from. So in that way, you can use one public address and so many port addresses while saving public address table, right? For 500 private address, you can still use one public address using as many port numbers we can. That is one idea of preserving public address using NAT concept. See, local IP address, local port, but you are registering it with some public IP address. Same public address for all the IP addresses, but the port number will be different at the outside pool. Pool of port numbers, but just one IP address. So that way you have pool of IP addresses with different port numbers. But still there are so many private network IP addresses. So all these private addresses, they're going out and they're becoming the same public address but with different port numbers. This is how you configure. You can configure inside. But here we configured on the outside pool, right? You can see the configuration we configured and compare it here. It's actually PAT. So you will also mention what? Port number. So tomorrow onwards we are going to talk about switching. It's a very big topic, okay? We will again briefly go through all these basics we discussed at the beginning of the class. Please go through all the slides and make sure you have all the right concepts. Then I will start from here. This is a big picture, okay? Access layer, distribution layer. You also read through this and read all the families here, okay? What are the different families? Tomorrow, reading this again. Why I spent 2 hours on discussing NAT? Because we have reviewed static route configuration, OSPF, how we redistribute static routes in OSPF, how we redistribute static routes in AIGRC, and we discussed different kinds of NAT. So we had a big picture of routing. Within that picture, we also discussed how NAT is utilized to save address space, how conservatively we can use public IP address by using single IP address and multiple pool of port numbers, and how the routing tables are exchanged in that. They are not exchanged, right? They are just redistributing on the router on whatever router we have configured as inside and outside interfaces. So we pick one router and we configure inside and outside ports, which we call outside NAT and inside NAT. On both ends of the NAT, we have another router. So we have pair of routers. So we configured a NAT pool on the outside NAT port, and that pool gave a randomly assigned IP address for whatever private address that is coming from the LAN. So whenever the private address NAT went into NAT pool, it translated into a public address and it went into a public WAN router. And the public WAN router identifies that route, that IP address, whatever it has received. So once it is received, when it is responding to that IP address request, it is sending back with the same public address name. So that public address, which is actually a private address, enters the router where we define the NAT pool and inside and outside NAT. So that router recognizes that this is the IP address that it has translated using a NAT pool, and it will reassign or retransfer it back to private address and send it back to inside NAT port. On the inside NAT port, it will identify the private address and it will use the local routing table to route to the LAN. That is the entire engineering behind the NAT. I will just explain again. This is the router we define. On one end we define as outside NAT port and one end we define as inside port. So this private address is coming to this router. So once it reaches the outside interface, it is routed to this interface, but not as it is. It is converted into a different public address that we define in the pool, which is 168.16.10. Instead of going forward as 171.68.1.0, it is going forward as 171.68.16. some random address. So this router will forward to WAN public server. WAN public server will send a response to 172.16.88. some IP address. Sorry, 170.68.16. some NAT IP address. But it is defined on this interface, but not to this private address. So it will go IP here and go here. Before forwarding here, there is a NAT pool we define on this interface, and this will again be transferred back to private IP address, and it will be forwarded to this local area using as it is private address, but not public NAT IP address. Any questions here? We can do a lab here. Pick public address here, public address here. In the NAT pool also define public address. But inside network use only 10.192.subnet private address. You know the private address, right? This is the private address range. So pick from them. I also pick, see here, if you closely observe, I picked private address from this range. But 170.168.192 is actually a public address. So inside out. So you can make this as a WAN public server. You can say this as a Tampa LAN. Whatever way. Still you are preserving it, right? These are all WAN public addresses. These are all private addresses. So what you do is, instead of picking just 172 everything 171, define this as 10 dot something and define this as something. Hello? Understood, right? WAN pool also I gave public address. NAT pool. Right, Kavya? I did not give private address.
Yes.
This will be much better picture because we are inside out, we are discussed inside out, but it's still the same picture. The WAN public address will go from here. Once it reaches here, it will go as
Something in the NAT.
access private, yeah. So it's come back to public address. So the local guys will think that it's a private address, but it's actually going to a public. Understood, right? So that is a problem. If you understood why we are configuring the NAT and how the commands are configured and how the pool mechanism works, that is enough. You don't need to confuse between which way should be inside, which way should be outside. Just understand the big picture here, which is how your network address translating. Since I configured outside pool, it will translate here. If I configure inside pool, it will also translate here. There is also one more command here. So IP NAT statistics. It will tell you the range, it will tell the name, different count, whatever it is. It will also tell what is the inside interface, what is the outside. How many did it translate so far? Go revision. Okay? Keep a PC here. Keep PC LAN. Configure the LAN in this interface, configure a switch here. Connect PC. Connect PC. Okay? Give them static IP addresses or whatever IP addresses. Connect to this. Ping the gateway. If they are working, then fine. So actually ping from here to here, and you will see what you will see. Number of translations. Static translation or dynamic or extended. Do that in the weekend and show me in the weekend class. Okay?